So this masterclass is about MLOps, and all of you know MLOps is a very important topic here. We'll discuss about MLOps. What is MLOps, and mostly here the focus is to understand actually how can we use MLOps in deploying our model, as well as what are the recent update happened. We'll also talk about LLM ops because GenAI is extensively used now. So we'll be talking about LLM ops, and there is something coming up is agent ops. That is totally new. So first thing, here, now, you all know that when we are talking about ML ops, we are building some sort of solution using machine learning. Machine learning models are good, uh, but unless you don't deploy them, unless these models are not shipped, unless they are not in production, they're of no use, like running them on Jupyter Notebook. And so if you build some model in your local machine and you cannot deploy that, then any application would not be built on top of that. So deployment is very important, and MLOps is actually helping that. So here we are going to discuss about life cycle, MLOps life cycle. How do we build pipelines? What is MLOps actually made up of? So what are the tools that we are having? And we'll also be talking about governance. So starting with end-to-end life cycle, scalable pipelines, CI/CD pipelines that we are having, we'll be looking into detail about them. And we'll also see like which other important tools like ML flow. There are some important tools when we are doing MLOps, so we'll be discussing about them. So production is required a lot of components, and most important part is about responsible AI. So governance is very important. So how do we manage the governance? Now, why does MLOps matter? What is the reason of why does MLOps matter? So according to Gartner, it says that like mostly 95% of models that we are building, it never reaches to production. That is the challenge. Most models, they are just POC or experimental. They never reach production. So there is always having some sort of dependency problems. Environment may not be consistent. That is the problem. It may not be having some sort of guardrails like alerting mechanisms. The continuous integration and the deployment uh, is lacking somewhere. So that is why uh, we need a proper mechanism where we can deploy this model. And as you can see, because 90% of these productions codes are not shipped to production, that is causing an issue here. Now, when we want to understand like how this has evolved, so initially we were having DevOps. DevOps came from software engineering. So if you want to deploy the model, and DevOps is helping. So we all know that when we have some applications, when we are having some software, you always will find there is some update of that. So normally you click on update, your system gets updated or your software gets updated. So DevOps was actually developed for this kind of updates, so that if you're updating something, your system should not be down, it should be running. Okay. And any application, so there should be a seamless integrations. So CI/CD pipelines are basically developed for that purpose only. Okay. uh, so that it doesn't cause any uh, issue when any model is running. So these are like continuous integration and continuous deployment or delivery. It's a process where if you're having any code chain, there is some update or whatever is there. So this could be automated, this could be completely automated. And so the deployment, the delivery that we are having, that should be having the manual effort should be as low as possible. It should be having less error and we should be able to update. So DevOps was there, but that was about software. So now DevOps can handle the code. But when we look at ML, ML is not only about code. What ML is having? ML, see, software will just be having the .py script. But in ML, what do we have? We have sample data, we have .py script. We also have model artifacts. Like when we train the model.fit, you save the model artifacts, Pickle file or Joblib file or any other file. So we have models, artifacts, and then there would be some other things. Okay. So what has happened? We need to monitor, we need to experiment that. So ML ops has evolved from DevOps, and now recently GenAI has been able to pick up. So we have LLM ops. So LLM ops is more about prompting, versioning using different frameworks like LangGraph, LangChain, and looking at the token usage, looking at the hallucination of the model. If you're building some RAG pipeline, so looking into the matrix, like RAGs use something called as ragas for evaluating the performance of those models. So building that. Now classical app is like just doing an unit testing, basic testing and deploying. In MLOps, you will be having a unit test, you will be having a data, you will have a model artifacts, that is called as model registry, some sort of threshold like accuracy will be 90%. All those things have been there. So this has been continuously evolving field that we are having. If you look at MLOps layer, what it is made up of, so the most important, if you want to map the tools to the layer like which we are having, okay, so the envelope system that we are having, the most important part is the data. Okay, how do you bring the data here? So like when we talk about data, you need to understand the complete ML life cycle. We need to understand the complete ML life cycle, and just to understand the complete ML life cycle, we also need to understand what is happening in the backend. Like what exactly is MLOps? What is the life cycle that we are thinking about, or what is the life cycle that we have been talking about? So to understand this, what you need to understand, you also need to understand about how does it looks like. So when we are using some of these cycles, okay, basically when we are developing. Now, if you look at ML life cycle, if you look at ML life cycle, how does ML life cycle looks like? I'll just show you one diagram here. Okay. So first, we would like to understand, we would like to understand what is the complete data science life cycle. Now you're seeing here right now is showing you the complete data science life cycle. How do you start? Start with your business understanding. Okay. Then you will be what you would be doing. You would be trying to do feature engineering first. If your data is having some noise, it is having some missing values, it is having some outliers. First, clean your data, convert your uh, text data or categorical data into a numerical values. Train your model, look at the performance of your model. So this is your modeling part. Once you have done that, okay, you would like to do a data acquisition, means build a pipeline where you can automate all these stuff, what you have done manually. So for that, we need you know, to set up a pipeline, set up the environment here. And once you have done everything, you would like to deploy the model. This is exactly happening. So data science life cycle is having different phase where you would be training your model, testing the performance of the model. how well the model is doing, and then it will be giving you some feedback. Again, go and retrain your model. This is how a data science life cycle looks like. So if you want to deploy this, if you want to prepare the model for deployment, what do you need to do? So first, you have to develop the model, train your model. When you say model.fit, what you're doing, you're trying to train the model. Once you've trained the model, you can train one model like linear regression, logistic regression, deep learning, any model. Check at their performance. Check the performance matrix. Okay. Also look into runtime issues, evaluation parameters, quality of the output. Look into all those things. Okay. That will help you to understand whether this model is production ready or not. Okay. Then you can go for the other part like deploying that model in production. We can think about building some sort of CI/CD pipelines if your model is ready. Uh, and then how do I deploy my model? Because you may have prepared the model in a certain environment like Python 3.10. What if where you want to deploy is having a different version of Python? Your entire code will not work there. Or any other library, let's say small library as updated. Again, that may cause a problem. So when you deploy it to production, you will be having your model artifacts also. But what is more important here is the continuous integration and the continuous deployment uh, uh, automation that you are doing here. So how do you do? If I take code directly and run it somewhere, it will cause an issue. The Python version may be different, other libraries may be different. So how do we manage that? We need an isolated environment which doesn't cause any problem. Okay, so that is why we need to have some sort of containers. Okay, we'll talk about them in some times. Where you try to exactly replicate whatever you have done in your local machine, having the same versions, irrespective of what the operating system might be there. Okay, so we have something called as Dockerizing, Kubernetes, and all, which are doing that thing. Then you can think about scaling them. Okay. Again, when you're doing that, when you're doing Dockerization, we're preparing an image of your entire artifacts, putting them into containers, verifying and testing the model. How is the model doing? And then maybe you can check the performance of the model. So CI/CD concept basically apply to traditional software engineering, continuous integration and continuous deployment. But now, again, it has become very important for ML also because when you're deploying a model, you should have to push the code somewhere. Okay, metadata all. So we follow this. So basically, how do you build these pipelines? So to build the pipelines, you need to have the model artifacts. You have to store them somewhere to do some test, basic test, whether the code is working or not, whether you can get a reason of why you're getting that output. Like in tree-based models, we get those feature importance. Then take a new data set, which the model has not seen, compare the performance of the model, and then deploy it to production environment. Deploy the model as a canary, means you can take a subset of data, test it there, different environments, and then once you have different types of strategies there, A/B testing, canary, like show one subset of model update to one customer, different parameters to different customer, check the performance of the model, and then you can go with a full deployments. As I mentioned, continuous integration is always important so that whatever update is happening, everything gets integrated. And you need a centralized version for this. So we have a software like Gits. Git basically it was designed by Linux open source system now. So if somebody is working somewhere, everybody can save the version. So like it is like a hub. So you can share your data, uh, push it on Git. You can do Git clone, and then everybody has the update of that. So Git is allowing to solve the problem. It's local. If you want to roll back to the previous one, It's helping mostly in data versioning and all those things. We talked about what are the artifacts. Artifacts are basically the trained file. So you would be having like, you would have done some sort of hyperparameter tuning, you would have done some sort of validation. These are the artifacts of the model. When you train the model, you save them. So here you can see, once we develop the model, like we prepare the artifacts, save them, we prepare the model for production. So you prepare all those things. Then what you will do, you will deploy your model. All the artifacts you will deploy. Now, once the model is deployed, it is working fine. But what will happen after some time? After some time, it may happen that the data on which the model was trained initially, the data uh, is changed. It's not the same. It happens. Customer taste and preference, they keep on changing. So it may happen that the model is not is not getting the same data on what it has been trained on. The pattern in the data has changed. So what will happen? The accuracy of model will go down because the input data itself is changed. So we should be having some sort of mechanism where we can monitor these. Let's say you keep a threshold of 90%. If your model accuracy goes below 90%, then there should be a feedback loop that okay, the model performance has decreased and we would like to increase the model performance. So we should be looking to the logs, ground truth. These all input important parameters we should be having. So if you look at, when we're talking about MLOps, those feedback, those logs that we have got, let's say there was a drift in the model accuracy when we are doing that. How did we find it out? By looking into the logs from 80%, from 90%, it came down to 80%, maybe 70%. Then what you should be able to do? Then you should be able to go back and retrain the model. This should not be done manually. This should be done by the tool itself. So like what we are doing in Jupyter Notebook, we go and run that. This should be done by the entire model itself, like the system that we are having. This is called as continuous delivery, CI/CD pipelines that we are building. So if there is any change in the input data and the model has detected that, it should be able to retrain itself. We have to set up all those retraining pipelines also, how the model will go for retraining. Ultimately, the model should be able to retrain, these things uh, when we are trying to retrain the model. Okay. So we just understood very basic things about these models, about MLOps. Let's continue where we were discussing about MLOps life cycle. So as you saw, how does it start? It start with, you first have to develop the model, have to do a feature engineering, to experiment the accuracy of the model. Okay. So when you're looking at uh, the training of the model, okay, so there might be some data that is not proper. You go and clean the quality of data. Then retrain the model. What you will do? You will retrain the model. Then test the performance of the model. How well is the model doing? Deploy that model and monitor the performance of that model. This is MLOps lifecycle. So if you look at the architecture, basically architecture is of 5 different tiers. So we are having this architecture made of 5 different tiers. One, on the top, you can see we are having an infra layer. Means when you're talking about infra, this is always going to be important. You know, how do you manage the resources, the GPU or the cloud? You're running it on cloud, or you're running it as a Docker or container. So Kubernetes, cloud resources, GPUs. If some setting is changing, how are you doing auto scaling? Looking into the infra part, then there would be a data part. Data part is basically how do we clean the data? If data is having some noise, if data is having, some other issue, how do we clean that? Then we have model layers. Model layers consist of the model versions, the model artifacts. We have a deployment layer. Deployment layer basically consists of those CI/CD pipeline. Just now we discussed about them. Or maybe building an API gateway, or applications where this entire framework can be automated. And most important, monitoring part. If accuracy of model goes down, how do we go and check how well the model is doing? Pooja, you raise your hand. Go ahead.
Yes, sir. Sir, you have mentioned these API layers in cloud, in infrastructure layer as well as in deployment layer. So I want to gain the clarity that where they have been implemented actually. This concept is not clear to me.
See, when you deploy that, you can deploy that on local. Local would be like REST API, Flask app you can develop. If you're doing it in cloud, then we require certain API. So in cloud like AWS, we have something called as Lambda function. Lambda function is again like API one, that is connecting those things. So there we would be having those gateways. So API gateways of, if you want to connect locally, so
Mhm.
you need to connect with the Lambda functions. Basically, you have to build those Lambda functions, or some other tools. So API gateways are like those are, if I send a request, my data,
Hmm.
so it should be able to pick it up in the cloud environment or on the local also. So local would be get and post we would be doing, or in cloud we would be having Lambda function managing it. Just an example of it. So like that, Lambda function is one example of how do you connect your model with the uh, other services. That way, we
Lambda function. Function we use for deploying in cloud and
in,
for local.
yes, it's mostly in AWS environment.
All right, all right. Thank you.
Yeah. So next we are having. So if you see the integration part here, data engineering we are having for MLOps. So MLOps is like in between machine learning, DevOps, and data engineering. What it is doing, so it is actually building a pipelines for observability, observable run, okay, looking into your data validations, maybe service level agreements that we are having. So this is these pipelines, they whatever pipelines that we build. Pipeline means you're building, you're automating this entire stuff. We're talking about data quality assurance, talking about your data quality should be proper, scalable process, the entire process you should be able to scale. So real life example like a financial company service. From it validate the transaction data using some anomaly. Like in that transaction data, there might be some anomaly. There might be some fraudulent transactions or something. So they have a tool called as Kafka. That is again a type of streaming like services which we are having. So here, for example, we are using from Kafka for monitoring data. So expectation here is to check the schema, the compliance, the range, statistical property of that. This we can manage that. So when we talk about data sets and feature versioning, so you have to update sometimes feature also. You have to scaling your model. So your features, your data change, your feature will also change. So first, we may update some code in the model, like in Jupyter Notebook, you keep on updating the same way. In your PY script also, sometimes you may keep on updating your code. So we can go with Git. Okay, data version control, like Git is one example. It takes the data model and the pipeline, can store everything there. And large file, if it is very large file, so on cloud we have S3 bucket, or maybe in Google or Azure environment we can store. And whenever it is required, we can get a snapshot of those data sets. It's easy for storing, and it is helping the teams to collaborate, like they can work on, because it's stored in a Git, so anybody can internally, anybody from the organization can access that. Feature store, we discuss whatever features that we are having. We should be able to manage the feature. Low latency, like when you're trying to deploy that model, it should not be taking a long time for making the predictions. And as we discuss, we can go for a cloud storage also, any cloud storage. So it can be offline, online, and that could be managed. Now, most important part is data governance. Very, very important. Like privacy. Okay. PI is the personal identification informations, name, email ID, phone numbers, all those data. How do you handle them? There should be some sort of masking, encryptions, and we should be able to control that. Tokenization techniques should be applied for sensitive informations like anything, like email IDs, phone numbers, anything that is there, it should not be used directly. Then some sort of masking can be done, access control can be done. Everybody should not be able to access all the data. Only the admin has the right and he can allocate that. Like that. So limiting the access to the data could be other thing. Then there could be a regulatory guidelines, like EU is having GDPR. Okay. Like that HIPAA, protected guidelines are there. In India, we have RBI, uh, who is setting up the guidelines for the banks and all. So there should be a guidelines, okay, uh, for handling this kind of issues. And then data lineage. Data lineage, try to see, you know, basically it's providing end-to-end visibility to how data is flowing, the source system, how transformation is being done. Okay, so it is giving those information here. Remember, when we have to deploy our model, we have to build an environment which could be reproducible. Means anybody running the script on which the model has been trained should also be getting the same output. Now, how do we do that? As we discuss, the environment reproducibility is very, very important for MLOps. And what are the ways of doing that? So one is Docker container. So package application, whatever dependencies you are having, libraries, configuration, anything that we are having, okay? So create an image of that, like just like copy. How do we copy? Do we take a photo, snapshot, and deploy them into containers? So containers are like virtual machines. You put them. So those are like Docker containers. So package application with all the dependencies, library, system configurations. Try to create an image of the model. Then you can manage the Python dependencies. How? By looking into the exact versions like conda install, pip install we are doing. Like that, we also have something called as poetry. Again, this is providing the dependency resolutions. Sorry, we can also build CI/CD pipelines where we can go for continuous integration, continuous deployment, standard format, okay, Docker files that we are having. So this is very important. Reproducibility is very, very important when you are deploying any model. Uh, it should work on if let's say it work on any machine where it has been developed, so it should be working on any other machine also. Next part we can talk about experiment tracking. So very, very important. How do you track the metrics? How do you track how the model is doing? Okay, whether it is able to reproduce or not. So we have certain frameworks here, certain platform. One of them is called as MLflow. This is an open source. This will help you to pack your model, registry, and deploy. Like that, we have another framework called as weights and biases. This is real-time visualization, like you can see. extensive integrations. We have Neptune. These are some platforms. Just to give an idea about MLflow, weights and biases, Neptune.ai. So what you can track here, you can track the hyperparameter tuning, the configurations, model metrics like accuracy, precision, recall, F1 score, over 100 epoch, 50 epoch, whatever you are doing. And then uh, model artifacts. What is the process of, what is the pre-processing that is required? Also, we can look into GPU utilization. How much of GPU the model has consumed? What is the memory consumption during training? Whether it is hitting the complete limit, okay, the training will stop there, or it should continue. So we have to look into this system, the infra, whatever we have got, data versions. We have to look into that. Next thing is that hyperparametering. So if your model is trained on certain parameters, parameter is something that model learns at the time of training. We cannot do much there. Hyperparameter is something that is prepared before training the model. That is something that we feed manually. For example, how many trees we have to build up. We have to mention that in random forest. Now, how do we know that this is 100 trees good or 50 trees good or 150 trees good? We don't know that. So we have a technique for doing that. Grid search CV is one such basic thing. So what it does, it evaluates all the parameters. We can also go with random search. So random search will go randomly. Okay. Search your data. This is like random. Don't go line by line. No, you go random anyway. Or maybe Bayesian optimization that we are having here. So hyperparameter tuning optimization is very, very important. Okay. Now, once you have done your hyperparameter tuning, then you need to pack your model. You need to pack it, somewhere, the model weights, inference file together. Where? In a Docker container. So you can see you've got a Docker file, create an image of that, store it as a Docker container from the production. For the production, you have to do that. So we can validate the schema, the JSON schema, how the NPT is coming. We can validate the configuration of everything. Now, when you're deploying your model, how do you want to go? Do you want to go real time? As and when data comes, it should go and make the prediction. That is called as online inference. Or do you want to go batch wise, like every 24 hours you collect the data and then send it to model for prediction? Or do you want to go streaming? Okay. How you go through streaming? By using AWS service like AWS Kafka or maybe Kinesis. This could be used for the streaming inference. Now there are certain frameworks which is helping. So if you see here, we have certain frameworks. So what it does, you can choose a model like here we have so many framework, Fast API, Bend to ML, Torch Serve, Langflow Serving. So these are all example of model serving frameworks. So you can select the framework. Like for example, you want to create a vision model which can predict certain anomaly, no? Or maybe face detection model you want to prepare. So you can do that by using all these techniques like torch serve or maybe TensorFlow serving. The here we have mentioned the strength of each one of them. This is lightweight, simple REST API. Bento-ML is again the end-to-end serving with adaptive branching. Torch serve is basically it's coming with the PyTorch integration. Then like that we have other things also. Now when you look at cloud, let's say you don't want to go on prem but you want to go to cloud. So cloud integration, mostly there are 3 or 4 companies. Google is one of them. It is having SageMaker models. It can do auto scaling on its own. It uses something BigQuery for making the predictions. We can build up the pipelines using. So Google is having something called as Vertex AI pipelines, where you can create everything there. Okay, and feature store for something. Same way AWS also. We can manage different things. It is testing the model accuracy. We can go with A/B testing. Yeah, so as you can see here, we have, these are the different cloud frameworks. We have Google, AWS, Azure. These are the cloud frameworks that we are having. So if you want to build a pipeline, this should be your pipeline. Like when accuracy of model goes down, there should be a trigger. It should go for a training. The model artifact should be saved. You can check whether the accuracy is fine or not, and then evaluate that and go for the deployment of that. Okay, so there are different. Now, when we look at infrastructure for deploying these models, Terraform is one example. Any cloud you can use that. Like that, we have Plumi, okay, which can also be used as an infrastructure code. Then we have AWS Cloud Formation, basic ones. Most important, GitOps workflow. It's working along with Git when we are trying to save our code and when we are trying to build some pipeline. So GitOps is very important for automated reconciliations. Okay, running that. So it's like it. Other important thing that we discussed was observability. Observability, like how do you check whether the model is doing good or not? How do you look at the performance of the model? Okay. So observability would be your logs, metrics, and the traces. Logs basically would be in a JSON format. Metrics would be latency or some score errors. For example, your model accuracy is dropping by from 90 to 80, 75. Okay. So you would be saving the metrics, looking into the matrix, looking into R square, or there's a latency, like it's suddenly the model is taking a long time to make a prediction. So there is some sort of issue that we are having. Okay. So there might be problem in the model drift and model performance. Drift can happen. Okay. Because there might be change in the feature or there is some change in the training data that can cause a drift. We can also have a concept drift. Okay. So these are the model drifts, but again, feedback loops can help for the model to learn. So continuous feedback will definitely be helping. I will stop here. Do we have any question? Anybody is having any question or any doubt? We can discuss that, and then I can talk about.
Pooja, I think Pooja has a question.
Yeah.
Yes, sir. Sir, my question was related to that slide where you were showing this streamlining phase, fast API and likewise REST API one. I would like to know the more examples of the companies which are using those APIs and what are the practical application in that.
Okay. Coming back to this
This
now.
one and a slide before this. Yes.
Okay. So see, let's say you have built an email classification model. Suppose you have a company which is banking service, and the customers, if they have any issue with respect to that, they can send you an email.
Hmm.
So you will collect all the email every 24 hours and make the prediction. Okay, whether it is customer service email or whether it is admin email or whether it is marketing or sales event. So this you will be running in batches, not real time. Means collect all data after every 24 hours. So this is called as batch inference. That will have a volume of data. scheduled like every 24 hours, every 6 hours. That is, the company will decide that. So there are certain tools, like for example, Apache Airflow is one such tool that can help. Like here we are giving an example like monthly customer segmentation. Monthly you want to do, or you want to do daily, or
Hmm.
you want to do hourly. This you can do. This is cost effective because you don't need to run your model every time. You
Okay.
once every 24 hours. So you can again stop it, like putting it into the cold storage, something like that. Stopping it, activating it after every 24 hours, like whatever interval you decide, 6 hours, 12 hours. So these are
Hmm.
batch differences. They save little bit of cost. This is not running 24/7. Now this is running 24/7. Means as and when my data will come, I will make the prediction. So this is little bit costly than batch inference. Definitely here you're stopping the service. You run it every 24 hours. For an example, here this is running all time. This is running all time. So whenever,
This REST API one will run all the time.
yeah, online inference will be running all the time because you want to make prediction for any data. So this is using REST API. This is latency very slow. You don't want latency. For example, I'll give you example. Let's say you build an application where anybody can come, check their civil score and apply for a loan.
Hmm.
Now, imagine if I come on I open the website of the app, I send my data, and then I'm told that, okay, come tomorrow, we'll tell you whether you are applicable or not. I mean, that nobody would like that. I want to know it right now. So
Yes.
it will not work here. But
Hmm.
if I have some issue, I send an email, you get a notification, okay, we will reach out to you in next 24 hours, 48 hours. Means what? That is going as a batch because that would be run in 24 hours. So there would be some service which you cannot run as batch. Then you have to run it in real time online. So
Hmm.
we can use REST API to do a real time, okay, based on traffic or whatever it is there. We can run that. This is batch.
Hmm.
This is streaming. Streaming means like how real time, we try to stream through certain services. So like here we have AWS Kinesis or Kafka. So where you're trying to continuously monitor like fraudulent transaction, you're monitoring all the transaction real time. Here
Hmm.
what happens? This is making prediction. This is more about you're trying to look into the influence, monitor the influence. So whether there is some issue or not, there is some drift in the data quality, this is what you're trying to monitor. So they are like, how do you run your model? Mostly that. Now if you see, model serving means you have to make a prediction. So you have to store your model somewhere and you have to develop those applications to run your model. Like how do I get the PY script on my UI? How do I connect it with my website? Your website is the UI. So what do you need? You need to build an API, a very lightweight. So fast API is like a lightweight API that we are having. So if you look at the official listing also, fast API. If I'm looking at fast API, so you can see here fast API, you can actually go and create some service and you can use fast API. So if you look at learn, they've given in more detail.
If
Uh,
any company is using this first API,
yes,
which one?
most of the companies, if you go to their website, most of the companies are using this. Now here, if you see, they have given some examples also like, uh, okay. So here right now on their website, if you explore, you will find, or even you can search it on Google also. If you
Hmm.
look at Fast API, only if I go to Fast API, mm, okay, this, see how do you create a project here? Now the company is using Fast API. You can find it here about them. There is not. much information available. But again, if you check here, so the companies which are using C, here we are having, okay, Microsoft, Uber,
Uber.
Netflix,
Hmm.
again. So there are so many, everybody, in fact, everybody, not only them, but everybody is using it. It is so simple. How do you create the main.py file? So you just get a fast API, build your, and then route and send the request, and you run this. So
Hmm.
like how Streamlit is working, fast API is also working in that same.
Both are having same deployment use case.
Yes, yes, you can replace a REST API, or maybe you can replace Flask app, whatever we have done with fast API. We can do that. Even
Nowadays, the GraphQL is getting more famous and trending, na?
yeah,
GraphQL.
correct. It depends. Like see here, we have some of these services.
Hmm.
Again, that will depend. Like GraphQL is using some sort of graphical ways to monitor how we are doing. So this will help you to do a rapid prototyping. You can build some microservices. Bento ML is another one. If I go to this
Hmm.
Bento ML, so if you see Bento ML, this is see inference. You can make a, so you can start building, get a demo. So they have a demo also. Can so you can even like on their cloud they have deployed. So Bento cloud is there where you can deploy. Okay, it is asking for me to log in, but uh, you can even bring your like LLM also deployed on their cloud environment, and you can use them for making. So they have these inference compute. You can check this one, any model. So they are telling you bring any model like Llama 4 model, DeepSeek model,
Hmm.
deployed on this Bento ML here. So this is not free. They have definitely some pricing for that. One would pay as you go, or maybe discount. So like that we have Torch Serve, TensorFlow serving, Ray, and different ones. Then if you're doing it on cloud, so these are the cloud service provider which can help you. Like Google is having something called as BigQuery. Azure is having SageMaker
Hmm.
for that. Now it is also having GenAI based applications also, along with SageMaker. They call it as a Bedrock. AWS,
Bedrock.
yeah, that can be used. Then Microsoft is actually having its own service. So MLflow is like one of them open source which could be used, or it is having Azure AI. It is also having AI Studio. Like they have different kind of services for the same thing, which can be used for deploying. Okay.
Yes. Thank you so much, sir. Yeah.
We were talking about LLM ops. I'll just discuss about this. So one way you can deploy the model is use the VRAM, like VLLM. So this is optimized form of the model that we are having, doing some sort of optimization. Other thing would be LangGraph, like how we are using LangGraph for building agentic AI. So as you mentioned, we have like some of the graphical applications. So LangGraph is also helping for deploying model, and they have something called as Langsmith to monitor the observability. Like that, Azure is also having Azure Phoenix, which for LLM observability. Like if you're building RAG-based solution or any other thing, they can go through these. Uh, this is Arise Phoenix. Now let's say you want to deploy your model locally. So what are the ways of doing that? One way is nowadays we want to run that on mobile phones, edge devices. So we have something called as ONX runtime. How do I run it on the local devices like tabs or maybe mobile phones? If you want to run it on your local machine, any LLM model, you can go with Llama CPP. Deploy your model there. Other way, Intel has come up with this Intel's toolkit that is called as Open Vino. This could also be used for the deployment of the model locally. Like we have proprietary model, we have open source model. So open source model can be deployed like this with some of these tools. And some of the examples like how certain companies have been using this. A UK retailer implemented this MLOps, and there was some drift in the monitoring that was able to manage. A retail e-commerce company did A/B testing, save some money, like checking which version of model is doing good. Same way, a healthcare company is using certain feature to understand why that prediction is coming. What is the reason of that? So using SHAP for explainability, like to find out why that output is there. Okay.